You're all still here? All right. Let's give them something good.
Let's do it. All right, thanks for attending, everyone. Great to see you all. We are here to talk to you about scaling collaboration in dbt Cloud. So hey, everyone, I'm Cameron. I'm a product manager here at dbt Labs.
I'm Jeremy. I'm also a product manager here at dbt Labs.
We're here to tell you a story about scaling collaboration through new workflows in dbt Cloud. So welcome to the Jaffle Shop. I'm no longer a product manager. Now I work at the Jaffle Shop. For those of you who don't know, a Jaffle is a toasted sandwich. It's very tasty. And it's not just a sandwich to us. Honestly, it is our craft. So Jeremy and I have a great time using dbt together as an analytics engineer and a business operations analyst. We spent countless hours at the shop. Sometimes we debate the best fillings for our Jaffles. I'm partial to ham and cheese.
I'm vegan.
OK, sorry about that. And sometimes we discuss how do we best serve our models and metrics. So sandwiches and data, we like them both. As the shop grew, we've built a dbt project that meets the company's relatively small-scale data needs. We're just a shop, right? So we have 9 sources, 28 models, and a few developers. The project mainly provides insights about our suppliers, finances, and sales. But it's really exciting that you're all here, because just as we're speaking, we just updated the slides. Jaffle Shop has been acquired by Jaffle Enterprises International. We've gone from a local favorite to a global sensation.
Thank you.
That's right, woo. So we're really excited about what will happen to our sandwich stack. The big question, and why we're all here, what will happen to our data stack? We're going to have to adapt to a larger organization with much more data. So this sort of mirrors what Luis was talking about earlier, right? As we expand to more data sources, contributor, and use cases, we're trying to serve thousands of employees who are hungry for insights. And as we grow, our data complexity grows as well. Imagine going from one shop to hundreds globally. Each of these shops has a need for both visibility and governance.
So the fine folks at Jaffle Enterprises GmbH brought us in to advise on their dbt implementation. They heard that we had a whole lot of success at our little Jaffle shop and wanted to know if we had some best practices to share, because they were starting to struggle with the complexities of scale. So there was one thing we knew really well, and that was one project. Just put it all in there. Stuff it full. Take a big bite. So one big, mega dbt project with thousands of models, many, many developers. We didn't want to silo data assets. We didn't want to lose lineage. This is what we were used to. And though it had worked really, really well for us at our petite Jaffle shop, it didn't work so well for Jaffle Enterprises GmbH. These are the criteria we're going to use to assess the different approaches that we're going to talk through over the next few slides. Things like technical performance. How fast does it feel to use dbt? How fast is it to load the documentation, to do development, to run your models? Things like discoverability. How can I actually know which is the right model to be using? Or what are the costs of actually using the wrong model by accident? Things like developer efficiency. How long does it take from me knowing the right code to be writing, the place to be writing it, actually getting that pull request merged with passing CI? And finally, things like governance. So not from the perspective of the individual, but from the perspective of the entire organization. Are we creating a neat set of data assets, or a messy, chaotic mess of spaghetti code all over the organization? On all 4 criteria, I unfortunately have to say the monolith did not work out. At what point does one project become a monolith? You kind of know it when you see it. Right? Things start to feel slow, very slow, much slower than they did before. It becomes really hard to find the right model, or again, you frequently find yourself finding the wrong one. Developers are getting frustrated because they aren't able to get their work done efficiently, and although everything is all in one place, it's not actually governed. People are reaching in and using intermediate models that they shouldn't. Models are being deprecated or deleted without appreciation for the downstream impacts of those changes because they're just too hard to assess. So we were interested in trying out some other approaches. Again, knowing at our heart that we really liked the efficiency, the speed, the delight that came with one small project, we thought, why not many small projects, each in their own corner of the universe, a silo, if you will, or a vacuum. Of course, this made developers on specific teams very happy, but we were giving up something very, very important, a global unified view of all the data, all the assets, all the lineage across our organization. Turns out it's not a price worth paying. So while we improved performance and questionably improved the efficiency of individual developers, questionable because if I build something and you build the same thing, not knowing that I built it first, are we really being so efficient? We didn't improve discoverability. If anything, we gave it up. And we certainly didn't accomplish the governance goals that we had set out for. So we're going to get to two more approaches, ways to stitch those siloed projects back together. The first, to install those upstream projects as packages in the downstream projects. So you have a foundational project which defines the core data models, which are then used in domain project 1 or 2, say marketing or finance. This is better in some ways, but all we've really done is recompose the monolith with the scaling challenges that come accordingly. And unfortunately, the worst performance and the most complexity is shoved upon the folks who are most downstream, tending to be the domain-specific business users, not actually the people who can handle that technical complexity upstream in the data platform. So that's packages, hit and miss. Finally, something that we caught wind of because it's interesting, and it's an approach that we've seen many folks use, a foundational project that creates a set of DBT models, exposes those DBT models, and then through some sleight of hand, those DBT models reappear as sources in another team's project. All well and good until someone in that upstream project decides to rename that upstream table. All well and good until that downstream team finds some new tables inside of Snowflake or BigQuery and says, I'm going to make a source for this, without actually talking to the upstream team. So while this has improved performance, again, within the scope of each individual project, these approaches don't really enable discoverability. We've given up true global lineage, and they don't really accomplish the governance that we're after, where upstream teams enter into specific agreements and sets of guarantees with the downstream teams that they're building for. It's a mixed bag. And this is the state of the world until, well, very recently. If you go back and look at the answers that the fine folks at DBT Labs gave over the last few years, it was, there's some trade-offs. You could have one big project. You could have several smaller projects. Your mileage will vary. And there have been some really nice talks out in the community, out in the world, about how folks have assessed these trade-offs, including a talk at this very conference last year. For different people, different approaches might make sense. There are pluses, there are minuses. But all in all, it felt like we were reinventing the same wheels, struggling with the same challenges. And it's something that DBT itself should have a better answer for, an answer that we could all, I don't know, standardize on. So before, we could choose up to 2, maybe, kind of developer efficiency, always this ambiguous, fuzzy one. And we were interested in knowing if there could be a better way out there. So we reached out to some of our friends. We in the international business community all, I don't know, visit the same.
We talk.
We talk.
We use
yeah.
DBT Slack.
That's right. We visit the same DBT Slack communities. So we talked to our friends at Siemens, at Cisco, at Fifth Third Bank, the folks who were just up on stage, trying to see how they had solved this problem. And what they had to share with us was a better way. That way, DBT Mesh. Domain-level ownership of data, end-to-end, from development all the way through to production, without compromising on governance or creating data silos. This is what Mark at Fifth Third Bank had to say. DBT Mesh enables us to make data mesh a reality. Ooh, it's an orange. By offering a simple, cohesive way to integrate and manage data pipelines and products across the enterprise using a single data platform. That's what it looks like for Fifth Third Bank. This is what it looks like for us, the Jaffle mesh. Before we have, frankly, a still nice view of the lineage graph on the left, and on the right, our domain-level ownership across platform, finance, and marketing. We're going to have a couple of demos where we'll show you what this looks like for us. And know that we're going to be doing these demos in 2 different places. In the dbt Cloud IDE, which you know and love very well, I hope, as well as on the dbt Cloud CLI, because part of Mesh also means meeting people where they're at. Different teams, different developers want to be working in different ways, and we want to be able to support that. We, as the Jaffle shop, Jaffle Enterprises, and also the fine folks at dbt. So what we're going to see here is someone using the dbt Cloud CLI to do development in this Jaffle shop Mesh platform project upstream. As mentioned before, there are these new governance constructs within dbt, things like model contracts or access and groups and versions, ways to actually prepare the stage for those models which will become public and will become the interfaces depended on, relied on by other teams downstream. What we've got going on here is building the stage products model in a way that's actually not going to work, because we made some changes to the columns in that model that go against the contract we had specified for it in our YAML specification. We don't want to be changing the names or data types of these columns, even if it makes a lot of sense. Right? Price USD, not so bad, not such a bad idea, but it's going to break our downstream users for little gain. So we need to be making these choices intentionally. We need a way to flag them in development, not just in CI, definitely not just in production. And then if it is appropriate to add a new column, make an additive change that isn't breaking, or possibly even create a new version of this dbt model to integrate that change and present it in a way to downstream teams that they can opt into over the course of a migration window with a clearly stated deprecation pathway, those are the things that we should do. So in this case, we've updated the contract of this model to match up with the SQL definition. But we're still going to find out now in continuous integration, as soon as we select modified models, that this is a breaking change to a dbt model, because we've renamed some columns, we've taken some away, we've changed their data types in ways that queries downstream may very subtly break or very subtly change their results. So we could use something like model versions to say, this is version 1 of the API for stage products. We're going to be rolling out version 2 and taking version 1 away over time. And all that looks like inside dbt is creating that versions config block, creating a new version of this model so that we can roll back the changes to v1, leave it in place, leave it as the latest version for now, and then have v2 understood by dbt semantically to be the same model with a shared set of configurations, but then within the data warehouse materialized separately and queryable, addressable individually. That was the producer story. And I do love the producer's story, a fan of musicals enough. But let's talk about data consumers. Here we're going to be inside the IDE. And now we're in the finance team's project, where we're going to be taking a dependency on this stage products model that we just looked at before. We know that this model is there. It's been marked for public access. It's not just something that we happened to find inside the data platform by accident. And we know that its structure is stable because it has an enforced contract on it. So we can do things like reference that model across projects just by writing ref. We can add logic to filter or pull those columns in or do other interesting things with it. And we know that those columns are still going to be there with the same names, the same data types, and the same constraints that can be enforced by the underlying data platform. In this case, because we are using Snowflake as our underlying platform, those would be not null constraints. In addition, of course, to the documentation, the tests, and the other guarantees that that upstream team is giving us. In this case, we're going to calculate margin, and we feel good about doing that using product price and supply cost, because those are the columns that are contracted for us from the upstream team. All we needed to do in that whole process, add that upstream project to our dependencies.yaml, write a ref with 2 arguments, add the logic we need, preview, build, run, merge to production. Renato from Siemens says, it's now easier to ref models from other projects, keep it all within a single tool without having to look up database.schema.identifier, the physical location of these tables, without needing to go first into Snowflake or BigQuery or Slack to send a direct message to that upstream team. Hey, what was the products model I was supposed to be using again? Which is the good one and which was the bad one? Finally, because I need to be able to own these models now as the finance team, all the way from development through to deployment, I need a super simple way to coordinate the deployment of my project's models with the models in the upstream project as well. That's what's coming soon to dbt Cloud, a super simple way to configure that just inside the job orchestrator that we're all very familiar with. So the dbt mesh. Performance? Yeah. All I need to do is parse, compile, and run the models within my own project. I'm not going to accidentally type dbt run and see 2,000 things running by incident or accident. Discoverability, thanks to dbt Explorer, which our BizOps friends Cameron will be showing us a lot more of very soon. Governance, yes, thanks to all the new constructs inside dbt, things like contracts and versions and access. And developer efficiency, oh, it's still the thinky face with an asterisk. Why is that? Well, this is a genuinely different way of working. If you're used to being the deity developer who gets to make changes all over every single project, any model that you see before you, it's yours, and coordinate those changes like juggling a couple of balls in the air, and merge it all to prod in the same magical instant to see it all takes place, that's not dbt mesh. That's actually not data mesh. It's not a service-oriented architecture at all. We have to make these changes in ways that are additive and backwards compatible and well-defined and scoped to the interfaces of the projects that we're working in. It is a genuinely different way of working. And it does not make sense for everyone. The folks it does make sense for are especially those organizations which are large and decentralized and have clear domain-level ownership by different teams, where that person, that mythical single entity who gets to press the button called run the whole DAG right now, beginning to end, that person doesn't exist. Instead, we have a whole lot of people, dozens, hundreds of people across different teams owning their data end to end. It's a different way of working. I, as one of those people on one of those teams, get to fully own the process of discovering upstream data sets, developing the changes that I need, and deploying those changes into production. It's a continuous cycle. Discover, develop, deploy. But this one person, this one cycle, no longer exists in a vacuum, nor does this circle expand to include our entire monolith of thousands and thousands of models. I can be one person, one analytics engineer, not in a vacuum, not in a silo, but in the context of many. And in the context as well of my business stakeholders, like Cameron.
Thank you, Jeremy. So Jeremy talked about the journey for data developers. His data team prepared the platform project, and now my teams, the finance and marketing teams that I work with as a business ops analyst, can use what Jeremy's team has prepared. And so first of all, we need to understand the public models available to us, whether for analysis or development. So collaboration is key here. Jeremy ensures he's developing the dbt project to meet the need of my team of analysts, and I make sure that we're using the right data. So it's really a collaborative process here. That's where you see the analytics engineer handing off to the business analyst, and a feedback loop where I can say, hey, can we add this column? Can we add this new source that we got? And continue enriching our projects. Our ultimate goal is to empower our shops, empower our shop owners to make the right decisions about which sandwiches they can sell, how they can make them taste better using their data. So Explorer is where my team of analysts can find the public models we need across all of the projects in the account. Explorer is our shared canvas with the data team. It's where we collaborate. So in this case, we're going to be looking at the finance and marketing projects. Explorer provides the overview of our company's data. We can see all of the different projects available in our account. We can understand how these projects relate, how the cross-project refs have been defined using public models. The public models available within each of these projects as well, so getting that sort of global view across the account. We can see the details of all of these different public models. When were they last run? Are they contracted? Can I trust it? Is it still a work in progress? You can see all of this information. You're also able to see which projects use a given public model, and then traverse to those projects and really understand how is this public model used across the account. If I change it, if I'm enriching it, who does that impact? So this is really lineage not just across models, but also across projects. I'm able to view information about each of these public models as well as the other models and resources within the project, where they come from, how they're used, and understand all of these interactions. And this is really important in a couple of ways. First, it's important for Jeremy's team of data developers, right? They make sure they're meeting our needs, they're providing the right data sets for us, they make sure that they're not breaking anything. I think we've all had situations like that, where you accidentally break something downstream, you didn't even know someone was using it. It's also important for my team. We understand what data sets should we trust, what should we be building upon, who do we reach out to if something's wrong or we need something changed, and truly understand the ownership of these different models. So we were talking with our friend Alex over at Cisco, DMing a little in the DBT Slack, and he mentioned it's exciting to see the direction of mesh for cross-project lineage break down these silos between teams, reducing node boundaries, improving parsing speed improvements, and enabling the possibility of one view for an account. And when we say one view for an account, we are talking about Explorer. It's how we understand what's defined within our projects and across our projects. It's a brand new way of doing that. So I will say, let's say you're working in a small organization. Let's say you're not looking to adopt DBT Mesh yet. That's totally cool. So we needed Explorer for the multi-project workflow. Even if you don't go that route, Explorer can power your DBT workflows. So Explorer helps us understand data assets within a project as well. So Explorer is essentially a map of your data pipeline. It updates with the latest metadata after each DBT cloud run. And the goal is to connect data developers and data analysts. So if you know what a DBT model is, you're going to find Explorer a natural way to understand your project. So you can view your project's lineage, find a model, view its details as we were talking about, look at its code, how is it defined, both the source and compiled code, look at the columns, and then something new for folks who are coming from docs is the ability to view test results, source freshness, all this different metadata coming out of DBT Cloud. So not just understanding what's the descriptive metadata, what's defined within our project, but how is it running? Is it healthy? Should I be using it? Is it sufficiently tested? Really driving trust in the data, not just for the data developers, but for consumers like me. I might commit every once in a while to the project, but ultimately, I want to empower our shop owners to use the right data to make their decisions. So Explorer is how we understand the lineage, understand what's defined, search for different resources, and even look at, for instance, what are the semantic models and metrics defined in the project if we want to use a semantic layer. Yeah, so now we can look at our whole DAG here, look at all the different details. And we were talking with our friend Gavin over at Sunrun. Sunrun has not adopted DBT Mesh yet, but they're active in Explorer, so we were trying to understand, is Explorer the right tool for us? Gavin mentioned, given the size and complexity of Sunrun's data infrastructure, Explorer is an ideal tool for them to understand visibility across their environment. What are the latest results? What's the latest metadata? And more of that will be coming soon. So Jeremy's data team can develop flexibly and efficiently in the Cloud IDE or Cloud CLI. Then my team of analysts can discover and use their public models, reuse their data products. Ultimately, we're empowering business users in the shops with fresh, relevant, and governed data to inform their decisions, like which jaffles sell best, especially for the vegans. And because it's DBT Cloud, it's backed by access controls, and provides visibility for admins to understand who's active and how projects are used. It's overall secure and centrally governed for large enterprises. So DBT Cloud has a lot of new features that help us collaborate around data at scale. Since models are governed, we can trust them for analyses to inform our company. Cross-project refs help us reuse public models across our many projects, or really just 3, but soon to be many more. DBT Explorer is how we understand what's defined, including across these projects. And the Cloud CLI enables our developers, like Jeremy, to build as they wish. We hope you try them out and share feedback. I hear the product team really likes feedback.
I hear they're here also.
I hear they're here too, and you can approach them, and they love to talk to you.
Yeah, especially while eating. Yeah,
especially while eating. So thanks for your time. We're happy to answer any questions, and really appreciate you all being here.
Thanks, everyone.
Okay.
We're not doing questions right now?
We're not?
No, in Slack.
OK, we'll answer questions in Slack. But thank you, everyone.